Ladies and gentlemen, will be the data that we will be going over today. Want to give a huge shout out to AANYAOH for sending me this data. Now, unfortunately, they don't have an about data set to actually see who has which levels of concern is it when it comes to hypertension. That's the only disadvantage that we have in this. But at least, based on what I've learned from dealing with machine learning, given some of the mentors that I had, I've basically learned from like one good person that understands the field well is Dr. Jason Brownlee from Machine Learning Mastery. Shout out to him. I will try to dig into more of his methods later in this episode here. So we look at education, right? The level of education they have, basically what we're looking at, one being the lowest level of education, and four mainly being the highest, right? And you see the ages here ranging from 33 to 68 years old. BMI ranging from 3 to 45.8, based on the statistics that we have shown. And current smoker basically says, current smoker basically talks about whether or not they smoke or not. Basically, one says no, two says yes, from what I'm assuming. Go down to prevalent hypertension. 0 basically means no, 1 means yes. Basically, 0 is basically normal, 1 is abnormal. Heart rate basically can range from 48 beats per minute to 140, based on the heart rate that's being shown. And this is the data set that consists of literally over 1,000 patients. If we see here, we don't have to worry about the activity overview, but at least you have an idea of what the data set is mainly about. So, ladies and gentlemen, we will be digging into the following packages in this episode today when analyzing this hypertension data, right? So basically the package that we will be opening up and actually dissecting are the following. Number 1, NumPy. 2, Matplotlib. 3, Pandas. And 4, scikit-learn. For those of you who aren't fully familiar with Python or just not really interested in coding whatsoever, or actually want to try and just dig into the life of a data scientist or a wannabe data scientist, however it may be, these are the packages that we would have to deal with in order to actually get the proper analysis down. So basically, NumPy is basically short for numerical Python. Python is basically mainly arguably the world's most popular software to actually run code and do mathematical formulas and equations and hardcore advanced analytics. Virtually every company uses it, right? NumPy has a library that consists of multi-dimensional array objects as well as a collection of routines for processing of arrays. Now, Matplotlib is a cross-platform data visualization and graphical problem library for Python and its numerical extension, NumPy. So the third that we have shown is Pandas. It's a Python package that provides fast, flexible, and expressive data structures designed to make working with relational or labeled data both easy and intuitive. Which Pandas basically aims to be the fundamental high-level building block for doing practical real-world data analysis in Python. And last but not least, scikit-learn, sklearn for short, which is the most useful library for machine learning engineering in Python, right? It contains a lot of efficient tools for machine learning and statistical modeling, including classification, regression, clustering, and dimensionality reduction. And I have a bit of a knowledge in that because I already have a degree in engineering as well as a master's degree in applied mathematics and statistics. Now let's get to the fun stuff. Ladies and gentlemen, we have all the packages loaded up onto Python here. Basically, we already have NumPy set up, Matplotlib, Pandas, sklearn preprocessing, scikit-learn, performing processes. And what we did, we basically imported some plotting packages as well. Basically, a package actually read the CSV file off of Excel. Scatter plot matrices, basically like a scalar involved. Basically, a train test splits actually manipulate the model, as well as some k-folds, cross-validation scores. Grid search cross-validation, basically a classification report to verify a confusion matrix. Accuracy score to measure validation. pipeline, the funnel in, logistic regression, and they have all these other regressive models. They have decision tree classifier, K-neighbors classifier, linear discriminant analysis, Gaussian native Bayes, SVC, AdaBoost classifier, gradient boosting classifier, random forest classifier, as well as the extra trees classifier, right? So we'll definitely dig into these in a little bit detail. All right, so the main models that we will be running are basically of the following. We will be running logistic regression. Basically what logistic regression does is basically estimates the probability of an event occurring between it based on a given gas set of independent variables in which the dependent variable is between 0 and 1. Probability and statistics, right? Decision tree method, right? Basically a decision support tool that uses a tree-like model decisions and their possible consequences, possible outcomes, which can include chance outcomes, resource costs, and utility, and possibly money and finance, right? K-nearest neighbor is another method that we will be actually digging up today. A non-parametric supervised learning method which can be used for either classification or regression. If K and N is used for classification, the output is a class membership where an object is classified by a plurality vote of its neighbors, with the object being assigned to a class that's most common among its nearest neighbors if K is greater than 1. Now, if K is equal to 1, then the object is simply assigned to a class of that single nearest neighbor, right? Now, if K and N is used for regression, the output is the property value of the object, which is the average of the values of the K nearest neighbors, which is only just 1, right? Another model that we will actually dive into to study that data set, linear discriminant analysis, which is the generalization of Fisher's linear discriminant, which you can look up in Wikipedia to find for more information, to find a linear combination of features that characterizes or separates two or more classes of objects or events. Another model that we will be digging is named Bayes, which are classifiers that are a family of simple probabilistic classifiers based on applying Bayes' theorem with strong independence assumptions between the features. And for more information on Bayes' theorem, you can always look that up on Wikipedia. SVC, right, supporting vector clustering, which is derived from supporting vector machines, which is a method used by supervised learning models with associated learning algorithms that analyze data for classification and regression analysis, right? AdaBoost classifier, AdaBoost modeling, basically used to improve performance where the output of the other learning algorithms is combined to a weighted sum that represents the final output of the boosted classifier, right? And then we have gradient boosting, right? Gradient boosting is basically a machine learning technique, right, used in regression and classification, which gives a prediction model in the form of an ensemble of weak prediction models, which are typically decision trees. And random forest is going to be the second and last one that we will do, which is an ensemble method used for classification and regression of text by building a multitude of decision trees come training time. Last but not least, we got extra trees. Extra decision trees basically having the ensemble machine learning algorithm that combines the predictions from many decision trees. All right, y'all, now let's go load the data set here and see what we can play with. All right, let it roll, because there we go. Now let's try to dig deep into the shape here and see how big this guy is. Basically see how many columns and rows that we are dealing with here. We get the shape. So we have about 1,008 columns overall with the data set. Actually 1,008 rows, excuse me, and 6 columns, right? Coming from the data shape. Now we have to look at types here to see what types we have, because in order for the model actually run and that data actually run clear, they cannot be run through objects. They have to be converted into numbers through FOAT64 up in Python. So we need to check to make sure everything runs so well, right? So far we know all of them are basically displayed, right? So if we try to convert this string to float as of now and see what we get, can't do it. So that means we're gonna have to try and remove certain lines in order for it to work, right? So let's focus on the head, okay? See what we get here. And now if we scroll down up there, and based on what we're seeing, based on the top here, we know we see the column lines and column labels, but it's not fully thoroughly cleared out, that pattern can read. So we're gonna have to do a little bit of data cleaning in order for this stuff to work, right? Given what we saw, right? Based on what we see here, based on the numbers on the left, is basically the number of patients that's there. Education high is basically being the highest educated, one basically being the lowest educated. BMI, we know what the variance is. Current smoker, 1 basically means no, 2 basically means yes. Hypertension, basically 0 is normal, 1 is abnormal again, and the heart rate is basically going to give the current measurement. Now let's go and move the top row and see what we get out of this. Okay, now it's out the way. Now we can convert the swing to flow and see what we get here. All right, already converted. And now we try to set the option to swing the maximum rows to 500. And we print the types out, see what we get. Okay, the D type is object, which really converted that. And now we try to look at class distribution and see if it makes sense here. And so far, everything is fully integer based, which we can see coming from the top here. Basically what's labeled on number 1, that basically deals with AIDS. If you measure on the data set basically by AIDS and basically what's common, they basically go for the group by 1, which would basically be a size here. And they basically measure how often that they actually measure how many patients have partaken by AIDS here, right? So I'm trying to go a little bit further and actually advance a little bit, dig. So I want to try and see if I can do some things here and see if we could try to focus on. One second, I want to try and get the BMI here, as well as hypertension, which is really key because I want to do a few more things and see what I can get, right? So let's play around with this guy here and see what we can run. Let's see the outcome here. Now, what we're looking at is the BMI, right? So if we group the people that actually have the BMI, basically majority of people that have like BMI sets there. Now really the key that I really want to focus on here, we know about current smokers, right? The education, that's a bit irrelevant. Prevalent hypertension, we know. Heart rate is basically important. So what I want to do here, I know they have some people that actually currently smoke, which is big, huge. So if we could try to do a couple more things here and see. Y'all bear with me, please. And I'm focused on 3 more things here. So we're just playing around right now. And you print the data set. Group by 4. Right, and the size is there, and then 3 is basically representing whether or not they have a current smoking. Education is a little bit irrelevant because at the end of the day, it's all about health. Yeah, it can knock yourself out, but if you don't even look through Google to actually get the health advice that you need, you know, I don't know what to tell you, right? So let's go and see what we can get out of these 3. So 3 is current smoker again. 4 is whoever the patient has prevalent hypertension is. 5 is heart rate. Let's see what we get. All right, so for 3, right? Prevalent hypertension, basically about 506. Basically don't have any basically 506. Basically currently don't smoke, and 501 people actually do. For prevalent hypertension, the vast majority of people based on the chart do not have any hypertension whatsoever. Basically have a normal that's basically prevalent, and 1 is basically abnormal, which is basically very, very serious there. And 5 basically deals with heart rate. You can see all the various heart rates that you see down below as I continue to scroll down. Basically on like who has the highest heart rate and who has the lowest heart rate, based on the findings that we share here. Now, we want to focus on the histograms that actually show the whole data set and actually get a feel of what we're dealing with. So let's go play around with this. Let it run for a bit. Okay, now, because due to the fact that we have a data set of over 1,000 patients, right? That's why you're seeing everything being a bit small, and it may not be a little bit clear, but you're getting the feel of like what I'm actually getting at this, right? So let's see if we can try and do some density plots here and see what we can try to get. Remember the key numbers, right? 0 basically means like original, 1 basically means age, 0 is education, 2 is basically like current smoker, the whole night. 2 is basically BMI, excuse me. 3 is current smoker, 4 is prevalent hypertension, as well as 5 being the heart rate. So let's go run the density plots here and see what we have here with the colors that are out there. So 0 basically deals with education level. Density basically deals with age based on the volume of who partook in the survey, as well as recording of who came by, who came out, which we have shown the plots and basically shown through groups. Now let's focus on the correlation matrix that we have here and see what we get out of it. Get the plot figures, right? Get everything like fully correlated. We'll see what stands out, which doesn't stand out, right? There's not really much that's actually shown that's actually in between. Most of it you see where you have that's in between 1 and -1. At highest is basically like 1, but it's not up in like the lower sets that are actually shown, right? So these are the findings that we have shown thus far when it comes to data visualization and data cleaning. So ladies and gentlemen, what we will be doing, we're going to actually split out the validation data set and actually run those models and see what type of comparisons that we could get to see basically which model is the most efficient for this data set here and what findings that we can have. And the aim of these data sets is trying to make sure that we find the model with the highest mean that's basically the most efficient. So that's really is the #1 goal, right? So what we will do, ladies and gentlemen, is basically generate some data set values here and construct some arrays in X and Y values. Basically want to have the responders here. Basically you have want to try and make sure you get like some predictors going as well as a response, right? So X basically we know is basically all the variables and receptors coming from column 0 to 5. That's all six columns there where I have them shown. And Y is basically the respondent basically main predictor that's there. That's the one that we may have to focus on. That's the goal that we need to deal with when it comes to heart rate, because that's basically the big key that can actually dictate whether or not, they could be in like literally serious jeopardy for hypertension or like heart attacks and the whole 9 yards. That's basically the #1 concern. We know we're going to definitely do it in 20% validation size, 7C coming by. And what we're going to do, we're going to do a training test split with basically the models actually repeating itself for the most efficiency about 7 times. Get the number of folds that's there and a repeat with repeated seeds with accurate scoring. And what we will be focused on are going to be 6 models here: logistic regression, linear discriminant analysis, k-nearest neighbors, decision trees, naive Bayes, as well as supporting vector machines. Those are the ones that we will be digging for the time being. So let's go start this out, right? Let's see what we get here. Let's run it. Boom. All right. Now we got all that stuff set up. And now we want to try and generate the results and create a model based on that, create some for loops, generating all of the information from the data set that's below. So we want to try and literally focus on the mean, as you see here, with the cross-validation results, as well as the standard deviation. But the mean we will be focusing on. And there will be a chart to actually compare these outcomes. So let's go run it. It will take some time. So y'all literally bear with me, because it will be a crazy doozy. Ladies and gentlemen, we finally have the outcomes for the first algorithm comparison that we have shown. And up above on the top right, you will see box plots of basically models that actually showing their performances based on the means, and you see the comparisons there, right, with the cross validation scores and k-fold, right? So on the left here, based on these logos, you will see the mean. On the right in parentheses, you will see the standard deviation. So basically on what I'm reading, we know logistic regression has a mean of 0.106836, LDA 0.096, KNN 0.052, 0.50, native Bayes 0.018, and SVM support vector machines is 0.109, right? So for support vector machines and logistic regressions are the ones that are currently in the lead right now, right? And now what we will be focusing on is adding a pipeline and make sure we scale it out, right? The scale of the models that's shown to see if we get like a different outcome, or try and tune a little bit and try and make sure we limit the noise and get rid of as much of the noise as we can as possible, and we will be getting the same results. So what we will do is present those results to you, and once we get done actually getting all this stuff presented, then I will be right back to get all the stuff set up. So y'all bear with me, please. Ladies and gentlemen, as you can see with the scaled algorithm comparison, you know, basically minimize the mean on the left side here, as well as the standard deviation on the right you see below. Based on what you see up in the graph here, supporting vector machines and the logistic regression are still up in the lead. When we see how far, SVM has a value of 0.104, logistic regression has a value of 0.101 for what has been shown. Now, all we're going to basically play around with, we're just going to try and like experiment a little bit deeper with logistic regression as well as supporting vector machines, and I will give you the outcome of each one in a bit. Ladies and gentlemen, we have the outcomes of the logistic regression tuning that we have just done. Based on our findings, the best iterations with logistic regression is basically the mean of 0.118014, using basically C as 0.01, basically like the confidence interval is basically 99% confidence interval, basically using the mode of penalty with an L2 and a solver, Newton CG, right? For more information on that, you could definitely look under Python when it comes to logistic regression, and they have all the other means and standard deviations below with confidence levels, right? C levels that they have here below. Now let's go work on the supporting vector machine. Ladies and gentlemen, we have just tuned the supporting vector machines model with the hypertension data set. And the best one that they found so far is a mean value of 0.119259, using the C value as 0.1 as the kernel with linear. And if you see based on where my mouse is pointing, you see the mean on the left, and in parentheses with the number inside is the standard deviation. Scroll down all the way below, and they have all these various forms here that shows you what they've listed that they actually came up with. Now what we will do is focus on the ensembles with eta boost, gradient boosting, random forest, as well as extra trees. Ladies and gentlemen, we have finally had the results for the ensemble algorithm comparisons with eta boost, gradient boosting, random forest, and extra trees. And what we see up in the graph here with the box plots that's actually shown, given the data sets that we have for eta boost here, it's basically a 0.110556. This is basically the highest with the ensemble. Everywhere else is basically laying flat. Whereas if we go a little bit further, supporting vector machines is 0.119, and logistic regression is about 0.118. So the winner, which model basically won the whole ordeal? Supporting vector machines. Let's go run it. So ladies and gentlemen, here we have the preparation of the supporting vector machines model. Here we have the scanner scaler to have it set up with on the X training model. And we basically transform the X training column here with a C of 0.1, where we rescale the X and have the training set for the Y column. Get the validation set in order, create the predictions in order, And then we will focus on getting the accuracy score as well as the confusion matrix and the classification report. And let's see what type of outcomes we get out of this one here. All right. So it looks like, based on what we're seeing, the mean that's shown with the prediction, with the value, is 0.1188, right? That's actually been shown with efficiency that they have here. And that's basically what the accuracy score is about. We rescale it. 48% of the heart rate that's actually been shown is basically barely in position. They got one support here. And this is the heart rate that you see on the left, right? 48, 50, 65, 65, basically we know they have like 12 having that. 70 having a heart rate, 72 all the way scroll down. If we scroll all the way down, because basically heart rates basically dictate whether or not it could be a strong chance of hypertension that they have. Going down, the accuracy we have is about 202, basically with a 0.12 of a F1 score. And up there we have precision that's shown, and with the recall shown. They see precision up there, recall, precision, recall. That's basically shown. And we'll just focus on the closing. You know what I mean? Now, ladies and gentlemen, all right, after reviewing all the findings and actually digging through most of the data that's based on the heart rate and like how it can affect like each patient based on actually finding the mean of what we saw in Python, you've seen it in real time. All right. Even though heart rate and hypertension aren't really fully linear, BMI and hypertension can definitely be linear. However, they can also deceive. It's not really fully coordinated. It all depends on whether or not the patient works out, whether or not the patient lives a fully healthy lifestyle, is very energetic, and lives a very affluent, very active lifestyle. You know, stays off the drugs, stays off the cigs, stays off the 420, stays off the vaping. You know what I'm saying? Stays of all this poison stuff. They try to like release it and stay clear of like his or her body, right? And they could be pumping iron. They could be doing like intensified training, aerobics, cardio exercises, you name the whole 9 yards. I.e. myself, right? I just got back from lifting, doing chest workouts and triceps workouts like around an hour or two ago, and literally pull out some dang muscle here. You're seeing some of the triceps on me. You try to flex a bit. You know, you see the triceps really start to pull. And, you know, the chest come by, works out, starts to flex a little muscle there, stretches a bit more. You see, like, the muscle literally forming. And I can flip it on the other end as well. I'm seeing some of the triceps forming here. It's literally no joke. Literally, barely any BMI. Flip it over, right? The whole 9 yards, you're able to see some of the muscle that's really fully formed over there, right? So you can be literally like intensifying your workout with resistance training, strength training, and literally bulk up like crazy, you know, pump literally a crud ton of iron, right? And still get a high BMI, but you still live a healthy lifestyle. You still eat right. You still get yourself energetic. You lay off all the toxic stuff in your body. You know what I'm saying? You can still like avoid hypertension. In fact, a normal heart rate for any person, you know what I mean, is mainly between 60 to 100 beats per minute, right? Anything over than that, you know, depending, like anything that's over that is mainly when you're doing like either intensified training or if you're literally undergoing hypertension, like the late Kevin Samuels did, God rest his soul. And it literally went so high to the point where it literally started pumping blood like no other. When you add in the alcohol, when you add in the energy drinks, you know, when you add in the cigarettes, it can literally accelerate to oblivion to the point where all of a sudden, boom, 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 quick heart attack leading to cardiac arrest, right? Or stroke leading to cardiac arrest, or potentially chronic kidney disease. You know what I'm saying? This stuff is literally no joke. And it lets the public know after literally looking at the data here, right? Letting you know that your health is literally number one, which is extremely important. All right? Extremely important. Yeah. See this right here? It's also good for you. Okay? You need to literally eat more of this often. Eat a lot more of this. It'll save your life. Mm. 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 Get so moisturized today. Mm. It'll save your life. You know what I'm saying? Really save your life. Alright? Lay off the fast food. Information. Lay off the 420. Your health is literally number one, because all you got is this life. You know what I mean? And if you don't take care of it very well, and you know what I mean, it's not gonna really be that great for you. You know what I mean? You could literally have people literally mourn for your death, like a quick death. You know what I mean? Dealing with trauma, family dealing with trauma due to your loss and what could have been. It's not worth it. It's really not worth it. And you look at Kevin Samuel's situation, right? Drinking Red Bulls every single day while he's running the show, while trying to bust his behind off, right? Literally trying to actually get his stuff in order. You know what I mean? Trying to get his image all set and right. You know what I'm saying? To improve for the greater good. You know. And it's a shame that his vision that he wanted to deliver is unfortunately cut short. But I know there's going to be some other people that are going to carry that vision for him really along the way. And he would be furious at many of us men, right? If we do not get our health checked in order, if we do not take our health very seriously in regards to that. And it's not just with men, but also with women as well. And what's Kevin Samuels, from what I've been reading, recommends women to be fit, feminine, friendly, and the rest I'll just let you guys figure it out. But the fit part is really, really important to actually get yourself as healthy as possible so that you'll be able to prolong your life, which is what is extremely important in order for you to actually live a fruitful life. And God forbid you fail to do that, you know, you worry about the whole fat phobia phase and got people literally dragging you for trying to actually getting yourself healthy, leave them alone. They're really not worth your life at all. You know what I'm saying? It's not worth it. You know what I mean? Just focus on you. Focus on actually trying to improve you. You know what I mean? And stop worrying about what other people are thinking. You know what I mean? Reduce the stress by any means you can at the end of the day. So, with that, what happened in a situation like this is extremely tragic, right? Months ago. But we can all learn from this situation on literally trying to take our health seriously to the best way possible. And with that, you know what I mean? Deepest condolences go out to Kevin's family. Deepest condolences go out to Kevin's close friends in regards to this very unfortunate tragedy. You know what I mean? I'm definitely going to leave it at that. You know, this is something that people actually need to actually drill on. Even though this data set is coming from 2021, it can at least give you like a good idea, right, of how each patient operates, what each patient mindset is on. And I know mainly doctors can actually relate this and actually analyze it from like a much deeper perspective when they actually check that patient out, and they'll be able to give the proper diagnostics and the proper medicine and like how to treat that patient. They'll be able to do it a lot better than like any mathematician or statistician can, right? So with that, for more information when it comes to these things, if you want to try and get yourself schedule an appointment with an actual internal medicine physician like my father, I have one there. The site's literally linked below on YouTube. You can literally find them there. All right. So with that, Christian from the Nerd Chronicles signing out. Deuces, deuces, deuces. Good night. That's so good. So good.